So various forms of quadratic equations. Today's goal is to rewrite equations in multiple forms. We're going to start with an really easy problem. Y equals x squared minus 2x minus 8. And the first thing we're going to do is we're going to take this equation that's in standard form and we're going to rewrite it in vertex form. Now before we do that, let's identify some things we know about this equation now that it's in standard form. We can see the y-intercept is going to be at 0, negative 8. I also can tell that this quadratic formula is going to open upwards because the number in front is a positive 1. And because it's a positive 1, or a 1 in fact, it also tells me that it neither compresses or stretches. It's just the exact same width as the parent function. So to put this in vertex form, that's everything we do now is based on what you learned on Friday. So y equals x squared minus 2x minus 8. I'm going to take this 8 and move it to the opposite side. To do that, I add 8 to both sides. Y plus 8 equals x squared minus 2x plus a blank spot. Then I take whatever the b is. Notice that it is a negative, don't forget that, and divide it by 2. Negative 2 divided by 2 is a negative 1, and I put a star underneath that. It's going to allow me to shortcut in a few steps. And last step is to square that number. Negative 1 squared is a positive 1. I'm going to replace this blank spot with a positive 1. It will always be a positive number. Since I added a positive 1 to the right, I must also add a positive 1 to the left. Y plus 9 on the left equals, now I would tell you to go through and factor this, but here's the shortcut. Whatever this number is going to go behind the x minus 1 quantity squared. The very last step is to move the 9 to the opposite side. So I'm going to subtract 9 to the opposite side. Y equals x minus 1 quantity squared minus 9. This is factored form. What does factored form tell us about this equation? It tells us the vertex is at 1, negative 9. It tells us that this quadratic function neither stretches or compresses. It's the same width as the parent function. It also tells me that the parabola opens upward. Okay, we're going to graph it. So I'm going to come over here. I'm going to make a pretty simple graph. I'm going to start by going over 1 and down 9. I just graphed the vertex. 3 weeks ago when we started learning how to graph functions, we were reminded about the patterns of quadratics. So 1, 1, 2, 4, 3, 9. How are we getting these? 1 squared, 2 squared, 3 squared. Working with quadratics degree 3. How am I going to use this pattern to graph this parabola? Well, because the number out front is a 1, it doesn't change the y. So from here I get to go over 1, up 1. Over 1, up 1, and then it is symmetrical, over 1, up 1. Then over 2, up 4, over 2, up 4, and over 3, up 9. Now I'm only requiring 5 dots, but I did in this case do 7 just so we could see where it crosses the x-axis. The domain and range of this function. The domain is negative infinity to positive infinity. The range, it goes down as low as negative 9, and it's included, and there's no limit how high it goes. End behavior. Our end behavior is, as I go to the left, it's going up, and as I'm going to the right, it's going up. The next step of this problem is I'm going to go back, by the way, go back here. Notice, by the way, as a reminder, in case you forgot this, A is a positive 1. A is a positive 1. When you work with the same equation, regardless of the form, A will be the same. I'm going to write this problem over again, and I'm going to flip to the back. You don't have to if you have enough room. Y equals x squared minus 2x minus 8. And this time I'm going to go from standard form into factored form. Now here's the deal. It's not always possible to factor. It's not always possible to factor. We can always put something into vertex form. There's a couple ways to do this, and I'm going to show you both ways. If you were here on Friday, you would know these two ways. So here's one way. 1 times negative 8 is negative 8. Is it possible to come up with two numbers that multiply to give you negative 8 and combine to give you a negative 2? What are those two numbers? Negative 4 and positive 2. Now here's what we do need to check to see if this is right. I want a 1x squared. Is this times this 1x squared? It is. So what does that mean? It means this number in front is a 1. This is factored form. Done. Now what does factored form tell us? It tells us three things. It tells me that my solutions, the roots, the x-intercepts would be at 4, 0 and negative 2, 0. It also tells me that this parabola opens up and that it neither stretches or compresses. It's the same width as the parent function. Is there another way you can do that? Grab your graphing calculator, type this in, x squared, subtract 2x, subtract 8, and graph it. And as we learned on Friday, we can go second trace 0. I'm going to do the first root to the left. So above, below, as I create the boundaries and back to it. Negative 2 is one of them, so I'd write down x equals negative 2. Then I'm going to find the second root. Below, above, and back to it. X equals 4. I'm showing you another way when you can factor. How do we represent it? Okay, I plug it in with the opposite signs, x plus 2 and x minus 4. Again, I reassure myself that x times x is x squared. I don't need to change the a, and this is our final answer. All right, let me check one more thing. That is all we have to do for this. Example number 2. Now, example 2 looks slightly different, and here's the reason why. Notice that the leading coefficient is not a 1. When it is not a 1, the first step you have to do is divide everything in the equation by that number. When this value is not a 1, you have to divide everything by that value. So divide by negative 2 to all terms. Now I'm going to simplify it. I know that this is really like a negative 1/2. So negative 1/2 y equals 1x squared minus 4x plus 3/2. The frightening part of sometimes working in fractions is easy because we have a calculator. Okay, we're ready to do the work. So just like the last problem, we're going to take this constant, we're going to move it to the opposite side. Opposite of positive 3/2 is a negative 3/2. 1x squared minus 4x, and it's always plus. Whatever I'm going to put here is always plus. Some students in previous classes asked, why can't I combine these two? Because they're not like terms. One has a y, one does not. What is the b value at this point? The b value is negative 4. It's always important that you take with it the sign of the b. So negative 4, and we're going to divide it by 2. I simplify it and put a star underneath it. And then I take whatever that is and I square it. I do want to show you a common misconception. Everyone here, I trust, knows that negative 2 squared is 4. But watch really quick. If you plug it in like this, negative 2 squared, you'll get the wrong answer. Because your calculator pretends or thinks of this as order of operation, negative 1 times 2 squared. That's how it reads it. So if you have a negative number and you are working with exponents, always put it in parentheses before you add the exponent to get the correct answer. Okay, so this is positive 4. I'm going to add it both to the left and to the right at this time. Plus 4, and over here, plus 4. On the right-hand side, I would tell you to factor this, but here's the cool thing. We get to shortcut whatever this value is. It's going to be x minus 2 quantity squared. Now on the left-hand side, I know out of these three terms, the one term I cannot combine with the others is negative 1/2 y. Then I'm going to grab the calculator and I'm going to type in 4, subtract, and I'm going to put 3/2 in parentheses. Some of you will do this in your head. That's okay. And whether you write 2.5 or you turn it back into a fraction is totally based on your preference. So positive 2.5. There's 2 steps left and we're done. We want to isolate the y. We're putting this again in vertex form. So first I remove whatever is not touching the y. Subtract 2.5 to both sides. Okay, next I want you to think, what do you need to do to isolate the y? And the answer is we're going to multiply both sides by the reciprocal. On the left-hand side, the 2's and the 1's divide. They simplify, giving you a 1y. That's exactly what we want. We want to isolate the y. And then I'm going to take negative 2 times the first quantity. Don't distribute through the parentheses. Can't do that with a square. And negative 2 times negative 2.5. Well, negative 2 times negative 2.5 is actually a positive 5. Vertex form. What does this tell us? Well, in vertex form, I can see there's three things here. I can see the vertex is going to occur at 2, 5. I can see that this reflects across the x-axis, meaning that it's going to open up downwards. I can also see that we're going to have a vertical stretch by a factor of 2, which means it's going to be skinnier than the parent function. Let's come up here real quick and say, look at the a is the exact same. It's a negative 2. This tells me the y-intercept occurs at negative 3. Again, it opens up downwards, reflecting across the x-axis, and stretches by a factor of 2. All right, let's graph this. Please make yourself a very simple Cartesian plane. Graph the vertex. And now write the pattern down. The pattern with quadratics: 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. And I only require 5 points to graph an accurate looking parabola. Now I cannot just use these points to immediate graph, because what's different is that my a value is not 1. So I need to take all the y's times an a value of negative 2. So 1, negative 2, multiply, 2, negative 8, and 3, negative 18. It's unlikely I'm going to go all the way to 3. How do I now use those points to graph the parabola accurately? Well, I'm going to start with 1, negative 2. This is my new origin, so I'm going to go to the right 1 and down 2. And the symmetrical point, to the right 2 and down 8. This matches what I have for a y-intercept. Please write down at this time 3 things. I'm going to give you 30 seconds. Domain, range, and end. The domain of this function in intervaltation would be negative infinity to positive infinity. The range, it is important the order you write this. There's no limit how low it goes. It does go up as high as 5, and we include that point in the function. The end behavior on both the left and the right is going down. The final task is going to be to write this in factored form. Once again, you can always rewrite something in vertex form. That's always possible, because every parabola, listen to me closely, every parabola has a vertex, correct? Regardless of where it is in the graph, every parabola will have a vertex. But not every parabola has x-intercepts. Here's an example. This parabola doesn't have x-intercepts. This parabola doesn't have x-intercepts. Or the x-intercepts that occur may be an irrational number, which means we can't factor it, okay? We can't factor it nicely. So here we go. Is this factorable? There's a couple ways to do this. So I'm going to start by, in this case, I think it's easier to do by hand. Negative 2 times negative 3 is 6. Come up with 2 numbers that multiply to give you 6 and add or subtract to give you 8. Anthony, please list them for me. Does 1 and 6 give you 8? What's another combination? 2, 3. Does 2, 3 give you 8? Is there any other combinations? Okay, then everybody, we're going to write not factorable. If it was factorable, we'd be able to easily identify the x-intercepts. We're going to take this in standard form, and we are going to find the solutions using the quadratic formula. A is -2, B is 8, and 3 is -3. Or sorry, C is -3. And I'm going to let the calculator do the tough work. So this is a -8 plus or minus 8 squared minus 4AC all over 2A. -8 plus or minus, I'm going to do the calculator for that work. Grab your calculator, and let's just call the discriminant. This will tell us inside if this number is positive, I know I'm going to have 2 real solutions. If this number is 0, I'll have 1 real solution. And if this is a negative, it means I have 2 complex, which means there's no x-intercepts. All right, here we go. 8 squared. The reason I'm not putting this in parentheses is because it's not a negative. Subtract 4 times -2 times -3. I received an answer of 40. If I leave it like this, although mathematically it's not wrong, it's not simplified far enough. So the only perfect square that divides nicely into 40 is 4, and I know 4 times 10 is 40. And I'm going to continue to simplify here. And then I'm going to divide everything by 2 because I know 2 is the highest number that I can divide it into -8, 2, and -4. So divided by 2, divided by 2, and divided by 2. Those are my 2 roots, the 2 x-intercepts. It is an irrational number, that's why I can't put it in factored form. So we're going to write this in vertex form. Notice that it has a 9 in front. I need to divide everything by 9. Y over 9, 6 over 9, 8 over 9. Looks ugly, but a calculator will make it easier. 1/9 y equals 1x squared. I can reduce this in my mind. 2/3 x minus 8/9. The next step is move c to the opposite side. So when it moves over, I know it becomes positive. So I have 1/9 y plus 8/9 equals 1x squared minus 2/3 x plus some quantity. Identify the b, -2/3, and we're going to divide it by 2. Grab that calculator. Put -2/3 in parentheses and divide it by 2. Turn it back into a fraction, and it equals -1/3. -1/3. Put a star underneath that. That's going to make our life a little bit easier. Now when I square that, I could put it in parentheses, or I could just do it using mental math. -1/3 squared, and I put it back into a fraction, is 1/9. So I'm going to add 1/9 to both sides. Plus 1/9 plus 1/9. On the right-hand side, I would normally tell you to factor this, but we have a shortcut. It is x subtract 1/3 quantity squared. On the left, I'm going to put a circle around these. On the left-hand side, I have 3 terms. And the ones I can combine would be 8/9 plus 1/9. Some of you will do that in your head, recognizing the number is 1. Others will choose to use a calculator, just showing you how it can be plugged in. Either way, you get an answer of 1. 1/9 y plus 1. To isolate the y, I'm going to first get rid of the 1. So I'm going to subtract 1 to the opposite side. 1/9 y equals x minus 1/3 quantity squared minus 1. To get rid of the 1/9, I'm going to multiply by the reciprocal, which is 9, or 9 over 1, on both the left and the right. On the left, the 9s and the 1s divide, and I'm left with, it simplifies to just y equals. Then I keep the 9 in front, 9 times quantity x minus 1/3 quantity squared, and then I have to also distribute it to the back number, minus 9. This front problem, this first problem in standard form, tells me three things. It tells me that the y-intercept is -8. It tells me that this parabola opens upward, and it also tells me it stretches by a factor of 9. It's a very skinny parabola. Notice the A is exactly the same. In vertex form, it tells me that the vertex is 1/3 comma -9. It tells me that the parabola opens up, and again that the parabola is stretched vertically by a factor of 9. You can write that in at a later time. Let's graph this down below. Okay, please go over to positive 1/3, I know it's a guess, and go down 9. Grab your graphing calculator. Another alternative to find those points, go to y equals and clear what was ever there. Please type in the equation fairly slow so you're not missing anything. 9 times the quantity. X subtract, then in parentheses 1/3. Once you end that parenthesis, we'll end the entire thing and square that quantity. And then subtract 9, not -9. Hit graph. I can see that this graph is going to look like what I have. It opens up, it's skinny, this is my vertex. Please do second table. Second table allows me to pick up some points that are non-decimal points. For instance, I can go 0, -8. 1, 2, 1, 2, 3, 4. 0, -8. I can go the opposite direction. I can go -1, 7. I can go 1, -5. And I want at least 5 points. I can do 216 would be off the graph. That may be the only one I have here. Let's see if I can get up to 216. 2, 4. Those may be the only ones I can have, but I know that so it's coming in like this and the opposite side. And obviously I did not draw a very good looking parabola. It should be symmetrical, but a little more difficult to do when your fraction, your decimal, is not directly in between 2 points. But I am able to get exact points looking at the table. Okay, what is the domain here? Domain is -infinity to positive, and our range, it goes down as far as -9, no limit how high it goes. And behavior in both situations, as you go to the far right and the far left, both are headed up. And now let's ask ourselves, can we put this in factored form? So I do want to review what we learned on Friday. Yes, we can do this by hand, but is there an easier way? So go up here, please, and type in the equation, 9x squared, subtract 6x, and subtract 8. I want to know, are there x-intercepts? And if there are, if they exist, are they rational numbers or are they irrational? Second, trace 0. Left bound would be above, right bound is below. I've created the boundaries, and in between those boundaries we will find the x-intercept. So one is -0.6 repeating. This is rational. You can predict the next number. So I'm going to write down -0.6 repeating. I'll turn it into a fraction later. Let's do the next one. Second, trace 0. We have learned this already. Left bound is below, right bound is above. Come back to it. And the second one is x equals 1.3 repeating. This is rational. You can predict the next number. That means that I can use technology to do this a little bit easier. So I'm going to type in negative 0.6 repeating. I'm going to put a lot of 6's below in back of it. Now when I hit math, fraction, enter, enter, I can see that this is equivalent to negative 2/3. Same thing, if you don't know what 1.3 is, I type it in, include a lot of 3's, and I can switch it into fraction form. Now why is that important? Because now I come over and I write y equals, I don't know exactly what that a is yet, but I can type in x, opposite sign, plus 2/3, and x minus 4/3. Recall it's the opposite sign of what you have. They're both reduced fractions, so I get to push up 3x plus 2 and 3x minus 4. Do I need to put a different number in front? Well, here's how you know. I want 9x squared. Is 3x times 3x 9x squared? It is. This is factored form. What does this factored form reveal about the graph? Well, it tells me a couple things. It tells me that I can find an x-intercept at negative 2/3 or a solution. I can also find an x-intercept or solution at 4/3. And the last thing we're going to do here is come down to the very bottom, please. Find the solutions to the functions using the quadratic formula. That's the key. They want us to show that.